Cardinality of a set, finite set, and infinite set. So in this lesson, we will describe null set, cardinality of sets, finite sets, and infinite sets. So I have a challenge here for you. So my first question is, how many days are there in a week? That's correct. There are 7 days in a week. And how about this question? How many of these days are weekdays? Yes, that's also correct. 5 days. So with our answer a while ago, if let's say set A represents the days of the week, so that means when someone would ask you what's the number of elements in A, that would be a 7. And that can be denoted as n parenthesis A. So the way we read it is number of elements in A. So your answer a while ago, that answers actually the question for cardinality. Cardinality refers to how many elements do you have in that specific set. Or the result or your answer is also called as a cardinal number. So for example, if set B includes the days in a week which are weekdays. So that means if someone would ask you what is the cardinality of the set, you have to identify the elements of that set. So for set B, if we write it in roster notation, you have Monday, Tuesday, Wednesday, Thursday, and Friday. So in other words, the cardinal number here is 5 because there are 5 weekdays. So therefore, we can write that this question as n number of elements in set B is equal to 5. Or to make that short, you will just say cardinality of set B is 5. So again, when someone would ask you, because normally in an exam, you will be given with this kind of denotation. You have to, the N with a parenthesis and a capital letter inside it refers actually to the number of elements on the set inside the parenthesis. Okay, let's continue with the next activity. So the activity name is Count Me In. So number one, F is a set of girl students of Blue Academy. So let's say these are the people included in Blue Academy. Okay, so looking at the figure, if we will answer this question, what is the number of elements of set F, or we read it as what is the cardinality of set F, our answer would be what? So you count the number of girls here. So that's 1, 2, 3, and 4. So the answer is 4. Okay? So I repeat, the answer is 4. How about if we will consider another set? So B is now a set of girl students in Blue Academy with a long beard. Okay. So looking at our students here in the picture, we can say that the cardinality of B, or the number of elements in set B, is correct. That's a 0 because you don't usually see a girl with a long beard. And as you can see in the picture, there's no girl here with a long beard. So if the result for the cardinality is a 0, that means that that is an empty or null set. So how do we define empty or null set? It's actually the set with no members or no elements. So it is denoted by this symbol. So just like a raster notation, we uses the braces. But usually in raster notation, we list down the elements, right? But since there's no elements here, no members, you just have to leave it blank, just like this. Or we can use the Danish letter, which is very popular, by the way, when you try to go higher. So this is the denotation for null set or empty set. But take note, you cannot combine both. You cannot place the Danish letter for null set inside the braces. It's either you use the Danish letter or you use the format for empty set if it's empty. The braces without anything inside it. So for example, N is a set of months in Philippines with winter. So if you notice, Philippines doesn't have winter as its season. So automatically, this is an example of an empty or null set. Or how about if we have another set here? Set Y containing the element X such that X is a month containing 32 days. So this is written in set builder notation. So we're trying to say here that the month which is unknown is a month containing 32 days. But it's usually 30, 31, or 28 only. So therefore, this is also empty. Okay, so aside from we can call a set empty or null set, there are ways also to describe a set by saying finite or infinite. So let's try to observe the following examples. We have here examples of finite sets and sample of infinite sets. Please pause this video for you to do some observation. Try to differentiate finite and infinite sets. Okay, so let's try to check whether your conclusion is correct or not by having some questions. So let's try to identify if the given set is finite or infinite. Okay, let's have number one. The elements are 2, 4, 6, and 8. That's correct. It's finite. Number two, 10, 20, 30, 40, 50, and so on. That's correct. It's infinite. Number three, sands in the seashore. Correct. That's infinite. Math teachers in a school. And the name of the school this time is XUJHS. That consider any school, okay? Yes, that's correct. It's finite. Okay, so how do we differentiate the two if that's the case? I'm sure that you got it right. Looking back in our set of examples a while ago, the finite sets here are 11, 12, 13, and 14, the A, E, O, U, 1, 2, 3 up till 72, an empty set, months in a year, and then set of math teachers. When we say finite, it's actually defined as an empty or if it can be placed into a one-to-one correspondence with a set of the form where n is a counting number. So I will make it very easy. If the cardinality is 0, 1, 2, and so on, you can actually identify its cardinality, meaning you can just count the number of elements in the set. That is finite. Why is it that an empty set is still a finite set? Because you can still identify that there's no members. And that is a zero. So still it's a finite set. Why is it that A, E, O, U, the vowels in the alphabet is a finite set? Because you know that it's just five. Why is it that the third set that we have on the screen from 1 to 72? Because we know that there are only 72 integers from 1 to 72. And then months in a year, we know that it's 12. So there is exact cardinality. In contrast, an infinite set is opposite to it. An infinite set has unlimited number of elements. So that's why the numbers that we have here, these this is a set containing the elements which are natural or counting numbers because it starts at 1, 2, 3, and so on. The ellipsis here is an indicator that it does not stop. So meaning we don't know what is the last number. We cannot actually identify the cardinality. Therefore, it's an infinite set. That goes to a set which is containing the element X, such that X is an animal in the ocean. There's a lot of animals in the ocean, and even there's more we have not discovered yet because of our limitations and technologies. So therefore, you cannot just simply identify the number of animals in the ocean, and that becomes an infinite set. Similar to the stars in the sky, there's a lot of stars in the sky, you cannot actually count them. So that's infinite.